All right, so it's working nicely now, but we don't want to apply the torque every frame. We really only want to apply the torque on the frame that it bursts open. So coming back all the way out here, let's define that frame in a common area, which we'll just call controls. So drop down a regular old null, press S to change its shape to something cool that befits its station as our control panel, like that. I'm gonna make it blue, because that's fun. And yeah, so come into here, parameters and channels, edit parameter interface, let's drop a folder right here between transform and root, and we'll call it controls. And so now we can put all of our centralized values that we need to read over and over again. So this breaking frame is something that, again, is definitely going to come up a bunch. So we'll call it break frame. And there it is. And it's going to be like frame 72 eventually, but so that we can debug stuff, let's just make it really happen very soon after the beginning of the shot. So frame 5 is fine. And I'm going to preemptively copy this parameter. I'm going to hide it because we don't need to see that there. Let's also, while we're out here, let's animate the safe. I hid this thing. Let's turn the old safe back on. Let's animate it moving up into the sky. So let's do, starting at frame 36, key your translate and rotate where it's just on the ground. This first 36 frames we'll use to like have the chains settle and show up. But after that, it'll float into the air. So we'll just have it, it'll just be subtle. We'll just have it kind of float a little bit like that and have it like turn back a little bit and then maybe even turn towards us slightly. So nothing crazy, just enough to give it this sensation that it's like magically hovering. The hope is that we're going to hand animate it up to this point, and then the spell will break here and it will fall on its little hind legs here and then like tilt forward and spill some of the coins out. That's the hope. We'll see what happens. So something like that. Very cool. Let's make sure too, didn't mean to make that. Let's make sure that that's actually being read in here. So I suspect that it's not. Yeah, so under the get safe in our safe sim area, make sure that we have into this object on. And now it will actually read that transform. Very good. Glad we caught that. And yeah, so into the sim, well, one more thing out here. We need this to actually not be active anymore. So we change it to 0. So the animated feature takes over. Now that it's no longer active, bullet will say, well, are you at least animated? Oh, you are. I should, as I continue reading from this piece's null, I'll see if there's a new position that I should be updating inside the sim. So coming back over here, we should see that happen now. If I press play, we see the torque is not being applied. It's animated up. Cool. Now we have that break frame set at 5, but nothing's happening yet because nothing really could happen yet. So let's make a pop wrangle. I'll put it on the post sim thing here. And we'll basically just say, hey, active is 1. And when does that happen? Well, we'll put an enable solver here. We could also just use an if statement up there, but I like to use the enable solvers. So we'll say paste absolute references, and we'll say when the frame is that frame, which is 5, then this will be true. Otherwise, it's equal to 0. So let's see what happens there. See, so it's off, 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 on. And on that frame that it's on, it's now been set to active, and it stays active after that. Now the torque is still being applied every frame forever after here. So what we should probably do is have these both come from the same thing. So I'm going to merge these two like this. Bunk. Bunk. Something like that. All right. And what else we want to do? We can control this constraint as well. We can have it start by being a glue constraint and switch it over. I don't know that we necessarily need to do it in this case because we have the whole thing is inactive, but let's say for completeness, I'm going to come back here to the safe sim, and I'm going to say, for this hinge constraint, you don't start as a cone hinge, but remember that you should become one. So next constraint name is that. For now, your constraint name is also just glue. And while you're a glue, your power is -1. This will just give you some versatility in case you decide to change up this simulation. It'll remain a glue forever until we change the constraint name to be cone hinge. And where we can do that is as a SOP solver on the constraint network over here. SOP solver, put it here. We'll say activate hinge. We're going to want the same thing here with this enable solver, like that. It's only going to do this on that one frame. Change this over to the relationship geometry, because that brings in all that stuff. And we're going to say primitive wrangler. We'll have the primitive wrangler only work on things whose next constraint name is cone hinge, meaning an unactivated cone hinge constraint. So that's what we do. We say the constraint name is the next constraint name, which is the hinge one. And we'll say the next constraint name now is nothing. That way it doesn't happen again. So it might seem like a lot of work for nothing, but it's just a good strategy in general. I mean, basically, if we didn't have this thing start by being inactive, we could have it start by being glue, and then and have the safe be able to be, let's say, knocked around by something, and then have the door spring open, rather than rely on it just being inactive. So in any case, so it still works, and that's cool. Looks like we're getting more force if we put it in that side. No, still the same. Bing. Yeah, it's not bad. We can, we can turn it up if we want. That was under the applied torque here. We could say like 50. Ding. That's pretty good. Bung. It's even like bouncing back a little bit off the wall, which I like. Bung. But remember, it's not actually colliding. It's just that hinge constraint doing all that work for us, which is going to be a common theme with the chains, which in fact is why I wanted to start by talking about the cone twist constraint in this setting, because it's all cone twist constraints now for the chains that are coming up. Very cool. So that's great. I don't want this door to actually interact with the chains for now. So I'm going to go ahead and turn off this thing that makes it active for now. So it's going to go back to being, or rather, I'm going to turn off the door. So no torque and no changing away from being glue. So now it'll still move up into the air. Well, I got to change the control panel first. To 72. Now it'll still move up into the air. And now it'll just fall. I hope that makes sense why that's working now. The door is just glued now because we said so. We said that this should be glue and you will become a hinge later. It can't become a hinge now because this is off. So it just stays glue. However, it is still all becoming active. So it's animated up to frame 72. It becomes active on frame 72. It falls. It's leaning forward kind of how I want it to. So they can, again, jostle some coins out once the door is open. And as all we'll have to do is turn on the torque and turn on the hinge to get the door back. Like that. In fact, really all to do is turn off the hinge thing. It can apply the torque all it wants to this, and it'll do something, but not much. But we'll keep it off anyway. All right, great. So now we're all done with the safe, basically more or less forever. With the last exception of, let's make a safe render. This is where we'll apply the materials later, but for now, it'll just give us a consistent place. Actually, I should go back in here, say, we'll put an out node on this guy. And you can put this wherever you want. You know, it might make sense to like push the whole thing down here. I don't know. I guess that's fine. So we got an out. Let's read that out in here. Just grab it, throw it in there. Now we have it. We want, this reminds me, we don't want the ground plane, so just bring in the RBD object itself, meaning this RBD packed object, not this ground plane, which is a separate object. So get safe sim. Again, we'll put a material SOP in here later, but that'll be at the end. For now, this is enough to see it like that. Cool. While we're here, I did want to say that looking at the safe, you'll notice that it's very angular, like this. This is not a stylistic choice. This is actually very intentional. Because watch what happens. Come over to the render view for a moment, and let's render what we see here, which is the safe. So notice that it's all still angular and terrible. What these actually are subdivision surfaces, which means that essentially this is all like a control cage. This is it's defining curved surfaces. Much like when we have a curve and we draw, change this to NURBS, when we draw these squared shapes, even though the points are squared or they're angular, it's defining a curved surface within. So that's what these are doing, except for at a surface level. So when we're back here in the render view, there it is. But watch what happens if I say on our render node, go into render polygons as subdivision. Look at that. Now they're all perfectly smooth. So once again, turn it off, or rather turn it off, and it's all angular and dumb looking. Turn it on. It's now infinitely smooth. It's as smooth as the renderer needs it to be. Cool. So that's why it looks like that. So it will look nice at render time as long as we keep that option on, which we of course will. So press stop, come back over here, and there you go. That's the safe.